Hey, welcome back to RamZland. Today I want to show you how to make an electromagnet, an electromagnetic train, and another kind of homopolar motor that's horizontal instead of vertical. Check this out. For this investigation, I'm using insulated wire, non-insulated wire. This is a coil of copper wire I made on a gimbal, some rubber bands, some bolts, sandpaper. These are 3-inch safety pins. And I'm using some wire clippers. I'm using D-volt batteries, AA batteries. These are N52 neodymium magnets that you can get at the hardware store. The first demonstration involves making a simple electromagnet. I would take a bolt, some insulated wire because it does get warm, remove the insulation on the ends, and start to wrap the wire around the bolt so that your wraps aren't overlapping, but that they're really close to each other, like so. You'll find that the number of wraps is correlated to the strength of the electromagnet. So the more times electricity flows in a circle, the greater the magnetic field that you create. So we've got about 10 to 11 wraps here. I tried to make them nice and close together. You can see what that looks like. So now I'm just going to hold the ends to a D-volt battery. So I have electricity flowing in a circle. That's going to create a magnetic field. But it's also going to make this bolt into an electromagnet. Check it out. I can start picking things up with it, like these safety pins. Let's see if I can get 2 safety pins on it. Just like that. Just a very simple electromagnet. Okay, this next demonstration is how to make a horizontal homopolar motor or a DC motor. If you remember last week, we bent a wire into this shape and we rested it on a AA battery to make a vertical homopolar motor. And you can see it spinning there as electricity flows through that armature in a circle. Today I want to do it with a D-volt battery. And so we're going to still use the same magnet that we used last week, but we're going to put it in the middle. And I'm going to take this rubber band and I'm going to wrap it around my D-volt battery a couple times so that it can hold a safety pin on each side. So it looks like this. Magnet on top, rubber band on the sides. Then I'm going to take those safety pins and I'm going to make it so that the bottom of the safety pin that has the circle is going to be on the top where the magnet is. And I'm just going to slide it underneath my rubber band. So it looks like this on one side. I'm going to do the same thing on the other side underneath the opposite rubber band. I'm going to slide it under there. So it looks like this on each side. Now I'm going to make my solenoid, and I'm going to take some of this red insulated wire that I have, and I'm going to unwrap about 18 inches, and I'm going to use my D-volt battery, and I'm going to wrap it around the D-volt. So I'm just going to wrap it like this, and I'm going to get maybe 4 wraps, and I'm going to leave a little bit left on the sides to wrap around the inner coil. So I'm going to take out the battery, and it looks like this. I'm going to take each end, and I'm going to loop them through the coil. And these are going to go through the safety pins to balance the solenoid over the magnet. So there's one arm, and here's the other. I'm just looping it through very quickly to make my solenoid. Now I want really good conductivity, so I'm going to take my sandpaper and I'm going to sand the ends of each arm. I'm going to make sure they're long enough to reach the safety pin. And you want them to be level with each other, like that. So there's a little bit of enamel on this copper wire, and I want to remove that with my sandpaper so that I get really good conductivity. So I'm just removing some of that enamel just by pinching it in the sandpaper. until you can see the shiny copper underneath. And do the same thing on this side. That looks good. Okay, so I'm gonna look at my battery here, and I want my solenoid to be close to the magnet, so when electricity goes in a circle, this will become an electromagnet that will repel the magnet that's resting on top of the battery. So I'm gonna run it through my armature here, like so. And you should sense a little bit of repulsive force there. You wanna adjust your arms so it's the right height. And if it kind of dips in the middle, just adjust the arms by bending them slightly. Almost there. Getting closer. I'm gonna try setting it on the table. Just look how fast it's going. Just a simple horizontal version of the homopolar motor or DC motor. Very cool. This last demonstration just uses an electromagnetic train. I took a lot of copper wire and I wrapped it around a broomstick to make this coil. Take your AA battery and make sure that each of the magnets are facing out north on this way and north on this way. So one side of the battery is going to be attracted to the coil and pulled forward. The other side of the battery is going to repel the coil and push. So you got a pull and a push. Make sure that the magnets are actually hanging a little bit lower than the edge of the battery so it makes connection with your copper. Look at that. You can see it run the whole length. Just like that. Okay, let's talk about your battery train. So you've got your coil of copper wire, you got your two magnets and your battery. One thing that's really important is that when you put the magnets on the end of the battery, the north end faces out on each end of the battery. So as electricity flows through that coil of copper wire, it creates a magnetic field, and that magnetic field is going to repel on the end of the battery, but it's going to attract on the front of the battery, pulling it through the coil. So if the battery is like a train, you want it to push through the coil of copper wire, and this happens when electrons flow in a circle through that copper wire. It creates a magnetic field, and that magnetic field is going to repel one end of the battery and it's going to pull the other end of the battery forward if your magnets have the same pole facing outward on both ends. That's really important. Now, if your magnets don't make contact with the copper coil, just slide them out a little bit on both ends of the battery. The magnets have to touch the coil so that the end pushes the battery forward and the front pulls the battery forward. And in that way, your battery is like a little train running through the coil of copper wire. And the copper wire works as a magnetic field pushing and pulling the battery along. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.